Hello class, welcome once again to our lecture for today. So this time we are going to solve the second example in finding the derivative of inverse hyperbolic functions. Alright, so we are given here a problem. Find the derivative of y with respect to x if the given function is given as y equal to inverse hyperbolic sine of hyperbolic cotangent x squared. Okay, so for our solution, so let us just copy the given function. So we're given y equal to inverse hyperbolic sine of hyperbolic cotangent of x squared. Okay, so that's the given. And to solve this, we are going to use the formula. So the formula here is, we will use this formula derivative of inverse hyperbolic sine. So the negative one here indicates inverse, h indicates hyperbolic. So derivative of inverse hyperbolic sine of x with respect to x, this is equal to 1 over square root of 1 plus x squared. But since we're not always given x here, so sometimes this is given as u, so let us generalize our formula as derivative of inverse hyperbolic sine of u with respect to x. So this is equal to 1 divided by square root of 1 plus u squared times the derivative of u with respect to x. Okay, or in another form or another notation, so this can also be written as derivative of inverse hyperbolic sine u with respect to x equal to 1 divided by square root of 1 plus u squared times the derivative of u with respect to x. Okay, so these are the formula that we're going to use. Alright, so in our given, so we have inverse hyperbolic sine of u. So this will be our u. Okay, so the whole thing here is our u. Alright. So our u therefore is hyperbolic cotangent of x squared. Then finding our derivative of u with respect to x, so derivative of u with respect to x. But our u here is hyperbolic cotangent. Then to find the derivative of this, so we have to use another formula. Okay, so what formula? We have derivative of, now to deal with this one, we have derivative of hyperbolic cotangent x if you can still remember, we have derivative of hyperbolic cotangent x with respect to x. So this is equal to negative hyperbolic cosecant squared x, or in general, so in general you can also write this as derivative of hyperbolic cotangent of u with respect to x. So this is equal to negative hyperbolic square cosecant of u, then times the derivative of u with respect to x. Okay, so we'll use this formula to find our derivative of u with respect to x. So in this case, we have here hyperbolic cotangent u, hyperbolic cotangent u. So this would be now our u. Okay, so derivative of this, so using this formula, or this one, but let us use this general formula. So this would be minus hyperbolic or negative hyperbolic cosecant, so this is squared, of u, and then our u is this one, our u is x squared, then times the derivative of, what is our u? Our u is x squared, so derivative of x squared with respect to x. So what is the derivative of x squared with respect to x? So in this case, we are going to use power rule. Okay, so the derivative of u with respect to x is equal to, this would be minus hyperbolic squared hyperbolic cosecant squared, okay, that's squared, then x squared, this one, then derivative of this is simply 2x, alright, or du over dx, derivative of u with respect to x is equal to minus 2x times hyperbolic cosecant squared of x squared. Okay, so that is our du. Okay, so going back here, so we'll just simply substitute. So finding the derivative of this using our result here. So we have derivative of y with respect to x is equal to, so derivative of, so something like this, the derivative of inverse hyperbolic of hyperbolic cotangent x squared with respect to x. Okay, so using the formula, so we already have the result, no? For this hyperbolic inverse hyperbolic sign, so we have this formula, or this one, you can use either of this or this one, but we generalize it, so we have to make use of these two, either of these two. So you have 1 over, so we have 1 over, or 1 divided by square root of 1 plus u squared. Our u squared is this one. Meaning our u is this one. So this would be cotangent or hyperbolic cotangent x squared. Then this is squared, right? This is squared. Our u here is squared. So this is our u, right? This is our u. Then you square this one also. Alright? Then times ito, derivative of u with respect to x. But we have solved this already. We got this one already. So we have solved this already. So you just simply substitute this immediately here. So times negative 2x hyperbolic cosecant squared times x squared. Alright? So this is our dy over dx. So dy over dx is equal to, so 1 multiplied by this, so this is negative. Okay, so this is negative 2x hyperbolic cosecant squared times x squared divided by the square root of 1 plus, so this part here can be written as hyperbolic cotangent squared x squared. Okay, so this is our final answer. So negative 2x hyperbolic cosecant squared times x squared divided by 1 plus hyperbolic cotangent squared x squared. So this is our final answer. Okay, so I hope this is clear to you, class. And I know that the confusion here will be on this part. So just take note, class, that if you are given, you just take note on this, no? To help you understand why here becomes, from here it becomes like this. So if you have cotangent hyperbolic or hyperbolic cotangent of x squared, then this is squared. Okay, so you can put this squared here. In other words, this is just equivalent to hyperbolic cotangent squared of x squared. So this is the equivalent. It's just like when you have sine x then squared. This is also equivalent to sine squared x. Okay, so remember this basic concept. It can be applied also here. Alright, so thank you very much, and I hope you were able to follow the steps now on how to solve this second example, derivative of inverse hyperbolic functions. Thank you, and see you again on our another example number 3. Bye.